Hello and welcome to this Vivado quick take video. The module reference feature of the Vivado IP Integrator lets you quickly add a module or entity definition from a Verilog or VHDL source file directly into your block design. While this feature does have limitation, it provides a means of quickly adding RTL modules without having to go through the process of packaging the RTL as an IP to be added through the Vivado IP catalog. Both flows have their benefits and costs. The package IP flow is rigorous and time-consuming, but it offers a well-defined IP that can be managed through the IP catalog, used in multiple designs, and upgraded as new revisions become available. The module reference flow is quick, but does not offer the benefit of working through the IP catalog. This training assumes that you are familiar with designing IP subsystems in IP Integrator. You can watch the quick take videos on IP Integrator as shown on this slide to become familiar with the IP Integrator flow. In this video, we will show you how to add RTL code to a block design in the IP Integrator tool. Further, you will learn how generics or parameters are inferred, how control signals are inferred, how AXI interfaces can be inferred, and other subtle nuances of this tool. Then, we will go over the limitations of the module reference feature and the differences between an IP and a reference module. Finally, we talk about how you can take the module reference RTL code and package it if you need to share this module as an IP. So let me demonstrate how we can quickly add an RTL module to the block design canvas. We start our design by launching Vivado and creating a new project from the quick start page. We will name the project mod ref project and specify the location where the project will be saved. We'll skip some of the other options for adding existing IP, constraints, or HDL sources to the project at this time, as everything needed for this project will be generated or added later. We select boards in the default part page and select the KC705 target board here. Let's review the summary screen to make sure that all the options have been entered correctly and click Finish. So here I have a new project which does not have any sources in it yet. In order to add HDL to the block design, first you must add the RTL source file to the Vivado project. We chose not to copy the HDL source files into the project. You can obviously copy the sources in the project if you so desire. You just need to make sure that you're working with the right source files in Vivado if you're editing your source code later. One of the things that should be emphasized here is that you should make sure that your RTL code synthesizes and implements properly prior to instantiating the code in the block design. This will prevent from unnecessary churns or fixing any design errors. Once the RTL module have been proved to implement successfully, only then you should instantiate the RTL block in the block design. Now let's create a block design and add our RTL source to it. Once the sources have been added to the project and your block design is open, you'll notice that the Add Module option becomes available in the context menu. As you will notice that the Hide incompatible modules option is checked by default. This option hides module definition in the loaded source files that do not meet the requirements of the module reference feature and so cannot be added to the block design. You can unselect this checkbox to display all RTL modules defined in the loaded source files, but you will not be able to add all modules to the block design. Examples of modules that you may see when deselecting this option includes files that have syntactical errors, modules with missing sources, module definitions that contain or refer to an EDIF netlist, a DCP file, another block design, or an IP definition XCI file. In this case, unchecking the dialog box shows a block design in this dialog box, which is grayed out, meaning that it cannot be added as a module. Let's select the top level module called Light SLB Adder V10 and click OK. Note that the module is instantiated on the block design. All the input-output pins are inferred from the source files. The IP is displayed in the block design with special markings that identify it as an RTL reference module. This helps you distinguish a RTL block from other IP on the canvas. An RTL module can also be added to the block design by right-clicking the RTL code in the sources folder and from the context menu selecting Add Module to Block Design. This option only works when a block design is open. Note that in the instantiated RTL module, we have 3 Axelite slave interfaces. These can be connected to a master using designer assistance. So let's create a simple microblaze design and connect it to the RTL module already instantiated. We add the microblaze IP to our design and configure it using the default settings for block automation. Let's also add a couple of other IPs such as the GPIO and the UART to complete our simple design. Now we can run the connection automation to connect our design to the microblaze subsystem. We choose to connect the GPIO to the onboard LEDs and leave all other options to their default values. As you can see, all the Axelite interfaces on the RTL module is connected to the microblaze through the Axe interconnect. Now, let's create a wrapper file for the block design and set that wrapper file as the top level of our project. Note that once the HDL wrapper for the block design is set as the top, the RTL module gets put under the block design tree in the sources window. Let's now talk about how generics and parameters are inferred in a block HDL. You will see some parameters defined in the top level module of our RTL block. These parameters are inferred and available to the user via the customization dialog box of the RTL module. To change these parameters, double-click on the RTL module and change one of the available parameters. In this case, we change a parameter called data width, which affects some of the output pins of the RTL module. In this case, we change the bit width to 64. Note that the width of the some output ports have changed accordingly. You must insert attributes into the HDL code so that clocks, resets, interrupts, and clock enables are correctly inferred. The Vivado design suite provides language templates for these attributes. You can access these templates by clicking on Language Templates under Project Manager in the Flow Navigator. As an example, I have a simple clock divider circuit in my RTL code. The output underscore clock pin should be declared as a clock pin in this case. In order to do this, we will open the language template for clock. We'll then copy and paste the text from the template and use it as needed in the source HDL code. In this case, I have declared my clock called output underscore clock as an output port and also declared its frequency as 100 MHz. Likewise, there are many other templates available for different kinds of interfaces such as Axe, video, and others. If standard naming conventions for these interfaces such as an Axe interface is used, the interface is automatically inferred by the IP Integrator. However, if the names of your ports do not match with standard Axe interface names, you can force the creation of an interface and map the physical ports to the logical ports by using the X underscore interface underscore info attribute as described in the language templates. You can edit the top-level source code of a module by right-clicking on it and then selecting Go to Source from the context menu. For other modules, look for the appropriate module to be edited in the source window and double-click on it to open it. If the module instantiation has changed, you will see a Refresh Change Modules link in the banner. Clicking on this link will update the module. You may see relevant upgrade-related messages via a pop-up window or in the tickle console. As an example, we've added an extra line in the source code and we have saved the file. Upgrading the RTL module pops up these messages in the tickle console as well as the pop-up dialog box. Now let's talk about some of the limitations of the module reference feature. Since a module reference is not an IP, you cannot specify the vendor, library, name, and version. As you can see in the Properties window for an IP that is selected on the block design, the vendor, library, name, and version associated with it is displayed there. The RTL module has a VLNV, as you can see in the property window here. However, a user does not have control over versioning of the RTL module. These versions are maintained internally by the tool. The RTL module definition cannot include other IP definitions, net lists, nested block designs, or another module that is set as out of context inside the RTL module. The only supported languages are VHDL and Verilog. System Verilog and VHDL 2008 are not supported at the top level of the RTL module, although System Verilog support will be provided in future releases. The Vivado IP Integrator does not let you associate an XDC file with a module reference as it does with an IP. You can synthesize the module as an OOC module, however, you cannot associate XDC files with the module. XDC files must be added to the Vivado project separately. Next, let's talk about some differences between an IP and a referenced RTL module. While a referenced module instance looks similar to an IP on the block design canvas, there are some notable differences between an IP and a reference module. An RTL module in the block design has an RTL marking on the component. You can also see some differences between packaged IP and reference modules when viewing the source files in the sources window. For example, when you reset the output products of a block design, all the source files, constraint files, and other metadata associated with the IP blocks are deleted. However, a module reference block just contains the source HDL, so there's nothing to reset. Also, note that a module reference block shows up as a module reference wrapper and not as an XCI file. Out-of-date IP are shown in the Report IP status window, or reported by the appearance of a link in the block design canvas. IP can be upgraded by clicking on the Upgrade Selected button in the Report IP status window. Out-of-date reference modules are also reported by the Refresh Change module link in the Design Canvas window, as we saw earlier. Finally, you can force the refresh of a module using the Refresh Module command from the Design Canvas right-click menu. The other difference is that while you cannot edit the RTL source files for a packaged IP, you can edit the source for a module reference. Now, since a reference module is not a packaged IP, you do not have control over the vendor, name, library, and version of the module instance. We talked about this earlier. For the module reference feature, there is also no parameter propagation across boundaries. You must use attributes as mentioned earlier to support design rule checks run by IP Integrator when validating the design. For example, IP Integrator provides designer rule checks for validating the clock frequency between the source clock and destination. By specifying the correct frequency in the RTL code, you can ensure that your design connectivity is correct. So now you have a RTL module that has been instantiated in a block design and has been verified. Let's say you want to then share this with other members of your team. One way to do this would be to hand over the entire RTL code, which would then have to be included as a part of a new project, and then the module instantiated, as we have learned in this quick take video. The other way of doing that would be to use the packager flow and package the IP. Once the IP has been packaged, it can be reused by other members of the team easily. This flow is described in another quick take video called Packaging Custom IP for using an IP Integrator. Please watch this video for more information. So in this quick take video, you've learned how to add RTL code in a block design and also learned about various features of this flow, such as inferring clocks, resets, generics, parameters, interfaces, etc. And we've also learned how to re-edit your RTL block design once it has been instantiated on the canvas. And finally, we have learned the differences between an IP and an RTL module. Thanks for watching this quick take video.